All right, we're going to go over Chapter 7 right now. After we do, I'm going to go over that. I handed you all out a program, okay? I'll give you a big hint. Keep that program. Not giving you an electronic copy, but you're going to do something similar to that for one of the problems on your test, all right? Not on Friday, but a week from Friday, okay? Just so you know that. This Friday, we do the Chapter 5 and 6 test. There are 2 questions, I believe. I'll check. There might be 3. I don't know. And I think one's a console and the other's a GUIs. All right? So, if you're following along in the book, I don't know what page we're on, but 269. Thank you. Chapter 7. All right. From now on, 2 big things for you to keep in mind. Number 1, no code repetition. So if you're doing the same thing over and over again in your program, you're going to write a method and call that method on an as-needed basis. All right, that's the first thing. The second thing is, going along with that, what we're doing, maybe if you've heard this term before, sometimes they call it the divide and conquer mechanism, where you take a big problem and you break it down into a series of subproblems. You solve the subproblems, and when you're done solving the last subproblem, you've solved the problem. That's what we're doing right now. All right. In other words, if you write a console program, when your test for Chapter 7 and 8, you will not be able to put everything under main. If you do that, you will have massive points taken off. All right, just so you're aware of that. For the test this week, since it's on 5 and 6, you can use methods if you want to. You don't have to use methods if you don't want to. Does that make sense? All right. And I think it's a question on the test, but I'm not sure. Sometimes people get confused. What's a function and what's a method? All right. A method is a function inside of a class. Did you hear that? So if you're using an object-oriented language like C#, you don't call them functions, you call them methods. If you're using a non-object-oriented language like C, then you call them functions. You don't call them methods. All right? So you can see we've got about, 7 or 8 different objectives here. Learn about methods and implementation hiding. You all know what implementation hiding is already because you do it. All right? And you're doing it, right now, if I asked you, for example, to, to go out and bring up the last document, or bring up this program. Let's just say I only gave you a hard copy, but let's say I gave you an electronic copy. If I said bring it up on your, on your screen right now, let's say that you had it on your desktop. You double-click the project file, you'd find the solution file, double-click that, or whatever. Do you physically know what happens when you're double-clicking those files and they're coming up on screen? I sure as heck don't. That's hidden from me. So when they talk about this hiding, that's what they're getting into. Because we live our lives like that. I mean, you do all sorts of things that you don't realize even what's going on underneath the hood, so to speak, because you just do them. All right? All right, we will write methods with no parameters and no return value. Well, if the method has no parameters, it has a set of parentheses, but nothing inside. Does that make sense? If it has no return value, what is its return type set to? What? Void. All right. Write methods that require a single argument. That means you have one thing inside of the parentheses. Write methods that require multiple arguments. Means you have multiple things. You've seen, I believe, earlier from me, something that looks like this. And I'm going to write this, but technically it's not. I'm not writing pure C# code. All right? But if I write something like this, int x equal 2, int y equal 4, int z equals add 2 x y. I'm going to keep this up there because there's quite a few things in here. And so I'm just going to put here ... because there's some more code. I don't care what it is. But here I'm going to put in static int add2, int num1, int num2. Return num1 plus num2. Now, this is not beyond any of your comprehension. So if I do this, and now I come in here and I write this, so I do a write line, and I say x, this is going to look ugly, but plus y does it make sense to you, all of you, that what that should actually print on the screen then is 2 plus 4 equals 6? Does that make sense? Bless you. Because if it does, you're well on your way to understanding this. This is a placeholder. That x is this, so that's the 2. This is just going to be a blank space with a plus sign with a blank space, so that's this. Then we've got y, which is 4, and that's this. Then we've got an equal sign with a blank space, so that's this. And then we've got z, which is 6, and that's this. Does that make sense? All right. Add2 is just the name of the method. We could have called it anything we wanted, but it's good to call it something that's reflective of what you're trying to do. Since we're trying to add two numbers, okay, so again, you can look at that and go, why didn't you just say z equals x plus y? Well, what if I wanted to, after this, what if I wanted to do this? And I wanted to use here A, B, and C. We'll give them different values. That'll still work. Now, if we've got that right line that's down here, and we change that to A, B, and C, that should now say 22 plus 45 equals, what is that, 69? Okay? 67. Thank you. But you get the idea, right? The reason that you write methods is so that you can call them repeatedly. And if you say, well, I don't get it, yes, you do. Every one of you gets it because you've been using write and write line the whole semester. Those are built-in C# methods. All right, you've been using read line. That's a C# method. All right, you've done some formatting where, if depending on how you've done it, you might have done use some built-in C# methods. All right, now what I want you to do is please look up on the screen because I'm going to throw a bunch of terms at you right now. All right, add two right there that you see in gray. That's what's called a method call. You are doing what's called calling or invoking the add to method. Sometimes it's called a call, sometimes it's called an invoke or an invocation. I don't make these words up, all right? Depends on the book you read. A lot of books use both terms, all right? If you look at what's in gray right there, the X and the Y that are in the gray, they're known as actual parameters. Those are their actual names. So imagine that I was writing something where I had to pass in my first name, and I had to pass in my middle initial, and I had to pass in my last name. You with me? Then I'd have to put in, the first parameter would be Jeffrey, the middle parameter would be P, and the last parameter would be Scott. Those would be actual parameters. So these are their actual names. Down here, would you agree that I did not use the same names as up there? Those are called formal parameters. That's on your test. Actual parameters are on your test. Formal parameters are on your test. So actual parameters are their names, the names that you actually used when you declared them. So again, in this example right here, A, B, and C are actual parameters. When you call a method, you've got to pass actual parameters. When you write the method, you can use either actual parameters or formal parameters. So giving you the example that I gave you before, if I was passing Jeffrey, P, and Scott in there, I could call them down here FN for first name, MI for middle initial, and LN for last name. So when you put in formal parameters, they don't have to be the same name as the actual parameters. And usually they are not the same name because normally you want to call the method multiple times. Does all that make sense? Because we've just gone through a lot of what's in the chapter. But I figured it was easier to show it to you like this. All right? And again, I'm just going to say this to you. If you're not reading the book and you're doing poor on the test, you've got yourself to blame. All right? All this stuff is in the book. That's all I can tell you. It's all in the book. All right. We'll also talk about writing methods that return a value. You know that already. I've shown you that, where you can return an integer, for example. And I just showed you that in the example. Pass array values to a method. And I want to put a couple terms in here. They're going to be in the next chapter more than this one, but I want you to hear them. All right? If you pass an entire array to a method, you pass it by what's called reference. What that means is you pass the address of where the array begins in memory. When you pass something by reference, any change you make is a permanent change. It's permanent. All right? If you pass something by value, you pass a copy. Now I want to show you something, and you should never, ever, ever write code like this. Everybody hear me? You should never write code like this. Okay, if I went back to this, I'm going to use this example. So I'm calling add2 and I'm passing in 22 and 45. Everybody with me? I could come down here and just do this. Return 786. I could literally do that. It would be really stupid to do that, but I could. Now it would say 22 plus 45 equals 786. See what I'm saying? Which would be a dumb thing to do, but you could do it. All right. The other thing I could do if I wanted to is rather than return num1 plus num2, I could come down here and say, no, you know what? I don't like the num1. I want num1 to be equal to 7, and I want num2 to be equal to 7. And then I want to return num1 plus num2. So what's going to happen is this is now going to print out 22 plus 45 equals 14. It doesn't sound like it makes sense, but you've changed the copies of these values. Those are copies because they were passed by value. So when you pass things by value, you should never, ever, for any reason, change the values of these inside of the routine. So you should never do something like this. But you can, okay? You should never, unless you're in Europe, you should never drive on the left-hand side of the road. Technically, if there's nobody on that side of the road, you can, unless there'd be a cop behind you, but you get the idea. But you should never, ever do this. Yes?
So, num1 and num2 are A and B because...
It's positional. Yeah. So since you passed A and since you listed that one first, they have to go together. Since you passed B and that one second, those go together.
And that's because the add2 is in front of the parentheses that match. Isn't that correct? Is that how
And that's well, what it does is it looks for a method named add2. Since you're taking and you're putting it into C, add2 must return something. All right? And that's why you've got the int right there.
Why wouldn't you use the same...
You could use A and B here. We could have made those A and B, but remember up here they were X and Y. All right, so a lot of times you just give them more or less generic types of names. It's not that you have to, but it's the other thing too is, let's say that these are really long parameters. Let's say that this is called the first number and the second number and the answer. It's much easier to put in, I didn't even have to do this. I could have just used N1 and N2 and then returned N1 plus N2. That's typically the way you see these things written because it's less typing. Now, back in the day when people were first doing this, you didn't have nice things like you have now, like IntelliSense. So if you named something with a really huge name, you had to keep typing it in or do a copy and paste. All right. Learn some alternative ways to write main. So far, when we've written main, we just have main, paren, paren. Don't have to do that. Main can do other things. And learn about issues using methods in GUI programs. So we're going to hit on all that. But again, a lot of the stuff that's in here we've already talked about, such as what is a method? Notice, it's an encapsulated series of statements that carry out a task. I would think that'd be a good thing to remember for the test. All right? It's, for lack of better words, it's a bunch of code that's going to define a task. In a non-object oriented language, this bunch of code is referred to as a function. In an object-oriented programming language, it's referred to as a method. Remember, we're going to do Chapter 7 right now, all right? And that's on beginning methods. We're going to do Chapter 8 tomorrow, and that's on advanced methods. Next week, we go into Chapter 9. We don't do 9 and 10 next week, just 9. So if you've wondered, well, what about this object-oriented programming stuff? That's Chapters 9 and 10. We're actually going to go through Chapters 11 through 14 pretty quickly, because much of the information you've already had. All right? So as it says, methods are invoked or called. Already mentioned that to you. And as mentioned, this is an invocation of the WriteLine method. You cannot put in WriteLine paren paren with nothing in it. If I try to put in this, in fact, let's just put it in our code here. If I had done this, I'm going to just hit enter here. I'd get an error. Can somebody tell me why I'd get an error in that? Because WriteLine is expecting something that it writes to the console. I've given it nothing. I've broken the rules, or however you want to say it. So WriteLine is an example of a method that requires arguments. All right? In the example that we just did, add2 is an example of a method that requires arguments. And I want to make sure, because Tiffany, you asked about this, I want to make sure people get this. There's nothing special about the words add2. Not to be funny, you could have called it Ralph, and it would have worked fine, as long as you called it Ralph here and here. But by taking and giving it a name that symbolizes what you're trying to do, it makes your code more self-documenting. All right, that's why you should do that. I mean, add 2 isn't bad. Some people would say, oh, it really should be add 2 numbers. Fine, then make it add 2 numbers. All right. So as it says, in this example, main is the calling method because main is calling WriteLine. WriteLine is the called method. You see, it's called. No, it actually typically is referred to as called. Calling, called. So the one that is doing the calling is main. The one that is being called is WriteLine. You can have methods call other methods. You can embed a method within a method. There's all sorts of stuff that you can do. In fact, if you please look up on the screen here, all right, I just showed you this example right here, okay? But I want to show you another thing we could have done. So I'm going to grab these 2 lines right here. I'm going to copy them to the clipboard. Now I'm going to comment them out. And I'm going to put them in again. I know that sounds stupid, but what I'm going to do is this. I'm just going to say this. For right now, I'm going to say int c equals 0. All right, and why would I do that? Because I can do this. Now what I've done is I've embedded the call to add2 inside of a WriteLine. So I've got a method inside of a method. Those are literally typically referred to as embedded methods. You want to guess which one of these methods we do first and why? Do you do the add2 first or the WriteLine first? Let somebody guess. The add2. Because it's embedded. It's inside of the WriteLine. So, you know, it's like putting parentheses in, and you work your way out. All right? Some people write all their code like this. Other people like to write it like this. This will execute faster than this. And the reason for that is this will break down to one line in machine language. And the zeros and ones, that'll break down to 2 lines. All right? So if speed is of the essence, you do it like this. If understandability is of the essence, which is what you should be shooting for right now, you probably do it like this. But either way should work. Does that make sense? What's that? You didn't have to make it 0. In fact, we don't even, you're right. We don't even need it anymore, do we? That's a good point. All right. Thank you. You're right. We don't even need that. There's no need for a C anymore. And you could say that that's another advantage of using it, because if you have too many variables, you start to get what's called code bloat, where you've got a lot of code in there that you really don't need. All right. Thank you. All right. Any other questions, comments, whatever? The implementation hiding, again, what they're saying in English is, you've all used WriteLine, but you probably, I don't know what happens internally in the system to make WriteLine work, and I don't care, because as it says, with implementation hiding, the details of that method's operation are hidden. All right? And please look, I can guarantee you this is on the test, these next 2 things. A method that uses another method is called a client of that method. I can guarantee you that is on the test. And I can guarantee you that black box is on the test. For years, when people referred to a computer, they referred to it as a black box. In other words, you see the computer in front of you, all right? But most people don't even realize or care that it's the CPU that's about the size of a postage stamp that makes your computer go or not go. All right? So as it says, a black box is any device that you can use without knowing how it works internally. I've given you this example before. If I do a Control P and I send that to the printer and I hit enter, I'm not going to, but if I do, I have no idea what happens to make that work. And I don't care. The only thing I care about is yesterday I sent a bunch of stuff to the printer in the office and it didn't work. And I was going to send it again. I said, wait a minute. Oh, because I sent it to the printer in here. All right. So that's the only time you care about something about the implementation details is when they don't work. This, for whatever reason, too, I don't know why, she gets so picky, Annie. Multi-file assembly is also on the test. So it says, to more easily incorporate methods into a program, it is common practice to store methods in their own classes and files. Then you add the methods to any application that uses them. The resulting program is called a multi-line assembly. Multi-file assembly, I'm sorry. But that's on the test. I still don't know why, but it is. All right. There's code bloat that I mentioned to you before, where, and this is a really good page. So if you're confused on this stuff, take a look on page 273 and on the explanation, which is back a page on 272. This whole thing that you see right here, this whole thing that you see right now in blue, that's referred to as the method header. All right, the whole thing. That's referred to as your method header. It's private. Most of the time when you create something, it will be either private or it will be public. Most of the time. All right? If it's private, that means it can only be used within that class, whatever class that you created it in. If it's public, it can be used anywhere in that class, and other classes can use it too. All right? The other one is internal. I'm not even going to get into that one. We'll talk about it a little bit when we get to the object-oriented stuff. All right? But this word private is usually referred to as either an access modifier or an access specifier. And what it does is it shows the scope of whatever it is you're working with. So if something is private, it has private scope. If it's public, it has public scope. All right? Static, if you put the word static there, all right, it means one, and it means you don't have to create an occurrence of the class in order to be able to use it. And if that confuses you, think about it this way. All right? If you want to sort an array, no, that's not a good example. There are, what you're going to see when we look at a couple of the math methods is that you can use the math methods directly without having to create a math object. All right? And that's what that means. If that confuses you, don't worry about it. Void means it doesn't return anything. Show welcome message is the name of the method. And paren means that there are no arguments. I would be, if I were you, I would look on 272 and 273 before your next test, because in some form or other, a lot of that stuff that's there is on the test. All right, they talk about accessibility, and there it is, public and private. Again, they talk about protected and internal. Let's just hold off on those until we get to the object-oriented stuff, and hopefully it'll make a little bit more sense. Fully qualified name. I don't remember if that's on the test or not, but if you remember, one of the things that I've been writing at the top of the program has been using static system.console. All right? And if I didn't have that there, then instead of write line, I'd have to be saying system.console.write line. So I use that using statement as a shortcut, so I have less to type. If I type the whole thing in like this, that's called a fully qualified name, because I'm putting it all in there. All right, and some of these names can get really large. That's why typically you use a using statement, and you use that as an alias, for lack of better words. All right, as a shortcut, whatever it is you want to call it, doesn't matter. They talk about static and non-static in here. All right, I think they're going to give you an example. All right, I'll give you one. Let's say we had another function, or another method, I should say, in here. So we'll say static double give square root. And we said here, return math.sqrt of, we'll have to give that a value, int x of x. All right? So now let's suppose that down here, where we had all this stuff, we had the int a, the int b, the int c, etc. I'm going to get rid of, put back what we had in here before. All right, I'm going to get rid of these dots. Okay, so let's say that we wanted to put a call in here, so we said this. Give double SQ equals give square root of b. Somebody tell me approximately what the value of SQ is going to be. What's the square root of 45? It's between 6 and 7, right? 6 would be 36, 7 would be 49. So it's somewhere in between there. The point is, when we do this, now control goes to this routine, and we pass it in here, not B. Yeah, we pass it in here B, which is 45. So in other words, what this does is it puts in the square root of 45. Does that make sense? And even though that's a double, what that's going to do is, since we made this, let's see, a double, it's going to say something like 6.5873 or something like that. All right? The point is, I can say math.square root. I don't have to go and create a math object to do that. I'm telling it to use the math class, and in the math class, I'm telling it to use the square root method. Since I don't have to create an instance of the math class, math is what's called a static class. That's what they mean by static, yes.
You don't have to convert into double.
Here, it automatically returns these as doubles. That's the way that the square root function works. And since it's returning a double and we're putting it into a double, all right, if we wanted to, we could, to make sure, we could come in here and say, you know, the value of b, we could put 45.0 in there. But it should work even if they're integers. Just the same way, if you're at your calculator, you type in 45 and hit the square root key, you should get the exact same answer as if you type in 45.0 and you hit the square root key. Okay? All right. We've talked about return types. Mentioned that to you before, that when something doesn't return anything, it's void. All right. Everything you put inside of the parentheses, so example looking here, you know, whether it's B or whether it's 45.0 or here it's AB, that's called your parameter list. Those are the parameters, that's the information that you're passing to the method so the method can do its job. All right, again, you should be able to follow this code. This is the answer to right here. So you come in here and main calls show welcome message, which writes welcome, then it writes have fun, then it writes enjoy the program, then it goes back to main and it says hello. You should understand how those lines print out. Literally what happens in a program, so you know this. The program comes in here and it sees this line. All right, show welcome message. Main has control, but as soon as it sees that line, main gives up control and it gives it to show welcome message. It does its thing. When it hits the curly, it comes back to main. If that makes sense to you, then you're well on your way to understanding this. If it doesn't, I'd strongly suggest that you read the chapter. We've talked scope before. Scope is the segment of a code in which something is used. All right? It's what's available. All right? You could kind of look at it that the scope of this program is this room. Everything that happens in this room. And it's between 8 and 12, Monday through Friday. All right? But usually when you think of scope in terms of programming languages, what kind of access does something have? Variables have scope, methods have scope, classes have scope. If you define something inside of a method, it's called local to the method. If you define something outside of a method, it's global to the program. You'll see what I mean in just a second. Again, if you look in there, you got main, all right? And notice there's an int a in there and there's an int a in there. They both work. They're two different a's. They're two different places in memory. If you said, well, what if you tried to use that other a from in here? Could you do that? The answer is yes, but it would take some work. And that's more what we'll talk about in the object-oriented stuff next week, the next 2 weeks. Again, if you're confused, start doing the you do it's in here. All right? Somehow, either on this test or the next test, for either 7 or 8, and we've talked about this before, a method can return either nothing, meaning it's void, or one thing. So a method can return either 0 or one thing. That's it. You say, well, what if I want to return more? You can return more. That one thing can be an array with 1 million things in it. All right, but it's only one array that it can return. Again, there's code here. This stuff now should make sense to you. There shouldn't be anything in that example that's figure 710, which is what? Page 281 in your book. You should be able to write something like that Now, the difference is, in the past, if we did a console program, we put everything in main. We're not going to do that anymore. All right? Then they go into all this. So if I confused you before over what's a formal parameter and what's an actual parameter, I would take a look at what's here on 282. All right? Because it's just a rehash of everything I went over with you. Again, methods can have one argument or they can have multiple arguments. So here's an example of something with two arguments. All right? It requires that you pass in a sales amount and you pass in a tax rate. Notice you're not returning anything, so this can be void and you can have stuff in here. This can be, int or something else and have nothing in here. You can have both of them, this be a non-void, and you can have one or more things in here. And quite often when you write routines, there's more than one way to write the same routine. All right? And it's not that one way is more or better or not better than the other. They start talking about a few things in here on the bottom of the page. So this is the bottom of page 285. Just hold off on that, talking about default arguments. That's in the next chapter. All right, so don't worry about that right now. All right. So, writing a method that returns a value. I want to say this. This may sound, if you're like, well, duh, then that's a good thing. But I want to make sure you understand this. Great. I'm going to grab all of this code. I'm going to copy it to the clipboard. I'm going to come down and paste it in again. You'll see why in a second. All right, you're passing in hours. You're passing in rate. Then you're creating a brand new variable that's called gross. It's a local variable. You're setting it equal to this, all right, and then you're returning it. Well, a couple things. First of all, does this have to be 2 lines? Not no, hell no. Why didn't they just do this? Okay? Second of all, why do you even need gross? Why don't you just do that? That's a much better way to write than this is. All right, but people who do this, it's not that they're bad programmers, but they're making the computer do a lot more work than it has to do. It just makes sense to do this because this is much faster. And think about it, if for no other reason, how many lines of code do I have to maintain? 1. How many lines of code do I have to maintain? 3. If you keep doing this and you've got hundreds of methods, it's going to be the difference maybe between 500 lines and 50 lines. I want 50 lines. Plus, this is going to execute faster than this will, because that's 3 statements and that's 1 statement. So you need a return statement if you're going to return something, just so you know, and I don't know why you do this, but if I want to write my own method, let's just say I'm going to write a method like this. I'm going to write private, and I'm going to say void, and I think they called it say hello. And they did a write line in here that said hello. All right? That would work. Just so you know this, I can do this if I want to. That's legal to put return, even if it's void, because there's nothing after the word return. You virtually never, ever see it, but you can do it. It used to be in the C language, you had to do that. Even if it was void, you still had to put the word return in. But they've changed that in the newer versions of C. Right? But in this language, you can put it in. I don't see ever a reason to do it, but you can if you want to. All right. I mentioned this to you before. There is an example of a nested method call. It's going to do the read line. It's going to take the output of the read line, and it's going to use it as the input to convert to int. All right. And then it's going to take the output of that, and it's going to assign it to price. That's a nested method call. There are 2 method calls in there. All right. And that's on page 288. You can return any data type. You can return a bool. And this was, I wish I had seen this before. This is the example, kind of what I showed you before. That's a POW function. I showed you a square root. But notice it says, when you look at this statement, the one that's right here in blue, when you look at that statement, cut it out, that's in blue there, this is what you can tell from it. It's from the math class because it's got the name of the class dot followed by the name of the method. It's public, all right? It's static because that class, you don't have to create a math object to use it. And it returns a double, okay? And it says, it's another example too of implementation hiding. I don't know physically what happens in the computer, so if I pass, what this is that's saying give me 2 cubed, 2, 3 times, 2 times 2 times 2. I don't know how the computer does that. I just care that it gives me back 8.0 because that's the answer I'm expecting. So the implementation is hidden from me. I only see the interface. All right. If you pass a single array element, just an element, so if I've got an array with 10 scores in it, 1 for each one of you, and I only pass 1 score in, that's passed by value. That's by copy. If I pass all 10 of yours in, so I pass in the array, that's by value. That's by reference. And again, if it's passed by copy, all right, it's literally that. Passed by value, sometimes called passed by copy because that's what it is. Passed by reference means if you change it, it's a permanent change. What if I wanted to do this? What if I wanted to pass in an array element, just one element, 1 score, and I wanted to change it? Could I do that? The answer is yes. That's what the next chapter is about. You pass it in as what's called a ref parameter. Ref short for reference. That's in the next chapter. So again, if you pass an entire array in, it's passed by reference. And if that still confuses you, and I used this example, I think, last semester, and I said, I don't know if it's this building, I guess this building right here is 751 Parr Road. If for some reason, it's not going to happen, but if for some reason tomorrow Rankin moved out of here and they moved someplace else and somebody else moved in here, the address of this place would still be 751 Parr Road. It's just the inhabitants would change. That's the key thing to realize when you're working with computers. Addresses inside of computer memory don't change. What's located in those addresses can change a lot as a program is going on. All right, next they go into alternative ways that you can write main. We've always written main like this. Now you should know what that means. Static means I don't have to create a main object. Void, meaning it doesn't return anything. Main, which is the name of the method, and paren, meaning there are no arguments. I can also write it if I want to like this. Static void main, string bracket args. You might say, well, why would you ever want to do that? I can set it up, so let's assume that I'm going to create a program that's going to be called write your name, all right? And I'm not going to ever ask you what your name is. In other words, when you run the program, I'm going to expect that on it you run it from a command line and you pass into the program Jeffrey, Paul, and Scott. Those would be these arguments. An array of strings. Okay, and if that confuses you, we're not going to use it, so don't worry about it. You can also write so that main returns an integer. Okay. All right. Issues using methods in GUI programs, understanding methods that are automatically generated in the visual environment. You already know some of those. You know that anytime you click a button on a GUI, you know that the click event fires. You know that. All right, appreciating scope in a GUI program. Bottom line with scope in a GUI program is this. If I've got a variable, so let me bring something up here. I don't want to do new, let's do open. And I don't know, I'll just grab this one. Hopefully this will show what I want it to show. All right. These variables, hopefully you can tell this, these variables in this constant right here, everything that I've declared, they're not declared in a method. They're declared at the top of the program. I could have even put them up before this, but they're declared at the top. Since they're not declared in a method, that means that anything that's in here in those 300 plus lines can use them, and I don't have to pass them in. So if you declare variables outside of any method, then they're global to your entire class. On the other hand, if I would have come in here and I would have grabbed one of these variables, for example, the sum, if I would have declared that in here, it would only be known in there. That's scope. All right. I would say, the stuff you should know for the test, know what public access is, know what private access is, know what static means. I think might be a question on non-static too, I don't remember. Know what a return type is, know what a parameter is, scope, know formal versus actual parameters. All right, let's quickly go over the review questions at the end of the chapter, then I'll give you another break, then we'll come back and we'll do the test review. All right, and then you'll have the rest of the period to work. All right, number one, a class can have D, any number of methods. So number one is D. Number two, why do you use methods in a program? Because they're reusable. And you say, well, what about all of them? It says main becomes more detailed. No, when you use methods, main becomes less detailed. Because all methods must be stored in the same class, that's not true. You can have methods in other classes. You say, no, you can't. Yes, you can. You already used WriteLine. You didn't create a class that had a WriteLine in it. All right. So number one is D. Number two is A. Number three, in C#, a method must include all of the following except you don't have to have an access modifier. We haven't used much with public and private yet. We'll use more as we go on. So number three is B. Number four, a method declaration might contain A, declared accessibility. That's the public or private, protected or internal. That's what accessibility is there. So 3 is B, 4 is A. Number 5, every method declaration must contain D, a return type. Either void if it's not returning anything, or the type, int, double, bool, etc. So number 5 is D. Number 6, if you want to create a method that other methods in other classes can access without limitations, you make it B public. So 6 is B. 7, if you use the keyword modifier static, you indicate that D, it's called without an object reference. So it means you don't have to make an object of the class. That's like the math dot that we looked at. So 6 is B and 7 is D. Number 8, a method's type is also its return type. So 8 is A. Number 9, when you use a method, you do not need to know how it operates internally. This feature is also known as C, implementation hiding. So 8 is A and 9 is C. Number 10. When you write a method declaration for a method that can receive a parameter, you include all of the following except an initial value for the parameter. And guess what? You can do that too. That's in the next chapter. You can give your parameters default values. We'll talk about that in the lecture tomorrow. So number 10 is D. Number 11, which of the following would be a legal call? The answer is B. You cannot call a method and put a type in there. So you can't call a method, and so that would mean A and C couldn't work, and the method expects there to be a parameter pass, so that would be illegal. So number 10 is D, and number 11 is B, as in boy. Number 12. All right. When you call calculate pay, it's assuming there's a double named rate. I don't like questions like this, but that's what she uses. So 12 is B. 13, in the method call. So if you are calling a method, I'm calling print data. I don't think this question is correct. It says in the method call print data, because you wouldn't do that. All right. Salary then is an actual parameter. I don't know why she has that other thing in there. Okay. There isn't a question like that on the test anyway. But number 14. The name of a formal parameter can be any type of legal identifier, meaning you name it. You don't name actual parameters when you call them or when you pass them, but you can name formal parameters anything you want. So 14 is C. 15 is B. I'll let you read that yourselves. 16 is C. Both are correct. 17 is D. 18 is A. 19 is B. Both methods execute. And 20 is A. When an array is passed to a method, it's automatically the entire array is passed by reference. Which one?
19?
C. Anybody need any of the other ones repeated? Going, gone. 12? 12 is B. Any other one? All right, let's take a break. Let's come back at 10 in 15 minutes, and when we come back, we'll do the test review for Chapter 7. As I've been doing too, for those of you who stay in here and or are slow typists, I will put this up. Oh, I gotta do the finished one. All right, I'll put it up in just a minute as soon as I find it. There, so those of you who are a little typing challenged, That's the ones at the end for Chapter 7 study guide. So if you want to pull out your Chapter 7 study guide, you can have all that stuff done. I've got to get a glass of water. kidding me, right? Unbelievable. It makes me wonder.
I'll give these back as soon as we get done going over the test review. 4 100s.